We power our modern world through a simple, brutal logic. We locate a physical resource in the Earth, pull it out, and burn it. Yet quantum physics reveals a different reality. Empty space contains a boundless background of infinite quantum fluctuations, constantly pulsing with what physicists call zero-point energy. The problem is how we think about this field. We continually look for ways to drill into it, treating the universe's fabric like an underground oil reservoir that we must physically pump dry. Our fear of a global energy collapse stems directly from this misconception. We aren't running out of raw power. We are simply misunderstanding how the universe stores and releases it. Energy is an active transition, the process of pulling a boundless field of potential states into concrete actuality. Every physical interaction, from a single atom locking into a molecule to the orbit of a planet, performs this translation every second. The bottleneck occurs inside that transition. When particles interact randomly, the movement from potential to reality gets messy, and a massive percentage of the energy dissipates immediately as heat and noise. Improving our infrastructure relies on engineering pathways that eliminate this internal friction, shifting the focus from finding denser fuels to building more efficient channels. When our channels are this noisy, the energy is lost as quickly as it is extracted. We are facing a pervasive failure of coherence, a state where our systems are simply too chaotic to capture the field surrounding them. We don't have to invent a machine capable of zero-friction energy transfer. Nature has already engineered a flawless, infinite energy channel, a star. If you look past the fire, you find a specific architecture. It starts with collectivity. A star is a macroscopic engine operating through the simultaneous action of 10 to the 57th power atomic actors. Those raw numbers only function because of coherence. Under extreme pressure, these billions of separate particles in the plasma state synchronize their movements. As the synchronization of a system increases, the internal friction between its parts drops away. Stochastic losses and resistance approach zero, and the energy passes through without degrading into waste. The massive output of our sun relies on orchestrating its atoms into this perfectly aligned channel to eliminate the friction of random interaction. To sustain that output, the star acts as a precise cosmic cavity. Through resonance, it tunes itself to exact frequencies, filtering and drawing specific atomic configurations straight out of the vacuum. Once that energy is released, the star employs accretion, feeding that output directly back into increasing its own gravitational pressure. This creates a cascading loop. Each cycle forces a tighter compression, extracting exponentially more energy than the last, all while balancing thermodynamic laws. Rather than depleting a static source, the star drives a self-amplifying cascade that sustains itself through a perfect feedback loop. This entire engine is held together by hovering at the threshold between total gravitational collapse and explosive expansion. By operating right on this edge of a phase transition, a state called criticality, the star's structure becomes maximally sensitive, acting as an antenna for potential energy. A star is a highly tuned architecture combining collectivity, coherence, resonance, recursion, and criticality to translate potentiality into actuality. Human engineering has spent millennia unconsciously trying to replicate this celestial blueprint. Our earliest technology was brute force. A campfire generates heat, but the reaction is highly scattered, wasting 95% of its potential as smoke. The Industrial Revolution organized that chaos. By trapping heat to move a cylinder, we introduced structural coherence, converting random thermal expansion into directed work. Today, we move electrons across continents through increasingly synchronized electrical grids, significantly reducing the resistance and noise of past mechanical methods. Mapping our entire history of innovation reveals a slow, steady climb toward tightening our channels, eliminating random waste, and increasing coherence. To solve the energy crisis, modern science must consciously engineer all 5 stellar mechanisms here on Earth. Modern technology already demonstrates these mechanisms in isolation. We utilize zero-loss coherence through superconductivity in the magnets of modern medical scanners. We are pursuing recursive amplification and collective atomic action inside massive reactors, attempting to sustain a microscopic sun for a few fractions of a second. But we still treat these principles as separate experiments. True, limitless power will only be unlocked when a single earthly device successfully integrates all 5 mechanisms into a single, unified architecture. The infinite field of potential states will never run dry. Our survival now depends entirely on building channels advanced enough to receive it.